Welcome all of you to another maths lesson.
So in the last lesson, we were discussing criterions for similarity of two triangles. Two criteria we finished. There is one more criterion. We'll complete these criteria, these three criterion today. Okay. So this was the definition. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. And the first criterion for triangles to be similar was if in two triangles corresponding angles are equal. If the corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles will be similar. Okay. And the second criterion was if two triangles, if their sides are in the same proportion, then their corresponding angles will be equal, and hence the triangles will be similar. That means the first two criterions are like this: the first condition, second condition in the definition of similar triangles. If first condition is satisfied, then the second will be satisfied. If second satisfied, then one will be satisfied. These are the first two criterions. Now we'll discuss the third criterion. Third criterion is like this: if one angle of a triangle is equal to one angle of other triangle, and the side including these angles are proportional, then the two triangles are similar. Okay, one angle each in two triangles are equal, and the sides including these equal angles are in the same ratio. Okay, look here when we talk about the sides, we are saying not equal, but they are in the same ratio or they are in proportion. Then what will happen? Those triangles will be similar. That means yes, their angles will be equal and their all three sides will be in the same ratio. Okay, so let me draw a picture here. Okay, suppose the name is ABC. Suppose the name is ABC, and there's some other triangle, some larger triangle. Okay, some big triangle. Okay, suppose name is PQR. And here given angle R is equal to angle C. That is given, and the sides how it is said in the theorem, sides including these angles are in proportion. That is, the sides including the angle R in the first triangle. Which are the sides including the angle R in the first triangle? PR and QR. And those two sides are in proportion with the sides including angle C in the second triangle. So the ratio will come like this: PR by AC will be equal to QR by BC. Okay. So this, if these two are satisfied, if angle R is equal to angle C, one angles equal, and if the sides including these angles are in the same ratio or in proportion, then these two triangles will be similar. Similar means the other two angles will be also equal, and the other side, one more side is there, that side will also come with the same ratio, that is PQ by AB will be also same to these ratios. Yeah, that's what we want to prove. The theorem says, and we will give a small proof now. Okay, so I shall take in both. Okay, so two triangle I shall draw fast. Okay, so two triangles, we need two triangles. Okay, ABC, suppose ABC, this one is ABC, and suppose the second one little big, we can give some different name, PQR. Okay, here given conditions are angle A is equal to angle P, angle A is equal to angle P is given, and also given the sides including these equal angles are in the same ratio. That is, AB by PQ is equal to AC by PR. So these two conditions are given. Angle A is equal to angle P, and the sides including angle A and angle P are in the same ratio. That is, AB by PQ is equal to AC by PR are given. We want to prove that they are similar. So it is enough to prove one of the criterion we already studied. either all three sides are in the same ratio or the angles are same. Okay, so we will prove that. So how we prove is just like we proved the first two criterions. So we want to take this AB length in the second triangle. So let this point be M, this point be N, such that as we have done for the previous proofs. So here the length AB is equal to PM and length AC is equal to PN. In such a way, you choose 2 points M and N on sides PQ and PR of the second triangle. Then what will happen? Are the triangle ABC and PMN congruent? Are the triangle ABC and the triangle PMN congruent?
Yes, sir.
Yes, by why?
SAS.
SAS, right. SAS, side, angle, and side. SAS a congruency criteria. By applying the SAS congruency criteria, triangle ABC will be congruent to triangle PMN. Okay, keep it there. Then you look here. If you consider the second triangle here, PQR, triangle PQR, then here PM by MQ, PM by PQ, this criteria, we start from the second condition given, that is AB by PQ is equal to AC by PR, that is given. Okay, so look here in the picture, AB by PQ. So we can substitute AB and AC. I think here itself we can substitute. What is AB? AB and
PM.
AB and AC, yes. AB is PM, we can substitute here, and AC is
PN.
PN. Okay, so PM by PQ is equal to PN by PR. PM by PQ is equal to PN by PR. And here, as we proved example 1 in the textbook, okay, here you can change this ratio into PM by MQ is equal to PN by NR. For details, you can check after the lesson. Example 1 proved in the textbook. Just to reverse, just apply the reverse, you will get this. Okay, PN by NR. So PM by MQ is equal to PN by NR. Now you can apply which theorem? Which theorem?
Converse of basic proportionality theorem.
Yes, converse of basic proportionality theorem. By applying the converse of basic proportionality theorem, we will get Mn is parallel to Qr. Mn is parallel to Qr. We will get like this. Mn is parallel to Qr. If Mn is parallel to Qr, some angles will become equal, right? Which angles?
Angle
This
Q
yes.
and angle.
Yes, this angle Q and M. I simply give name like this. Angle Q is equal to angle M, and also angle R is equal to angle N. Okay, and in these two triangles, in triangle PMN and triangle PQR, two angles are equal, I wrote here, and the third angles are common angle. Okay, so these two triangles are similar. So now look here, we have written here triangle ABC is congruent to triangle PMN. Triangle ABC is congruent to triangle PMN. Okay, and this triangle ABC, the angles of triangle PMN, triangles of triangle PMN are equal to angles of triangle PQR. So connecting these two ideas, we will get angles of triangle ABC is also equal to angles of triangle PQR. And hence, by the first criterion, since the angles are equal, they will be similar. That is, triangle ABC will be similar to triangle PQR. And that's the proof. Okay, I repeat once more, then we will go to the examples. Okay, look here, the third criterion says that if in two triangles, if one angle in each triangle are equal and the sides including these angles are in the same ratio or in proportion, then we can say these two triangles are similar. Okay, so we brought two triangles here, namely ABC and PQR. Then angle A is equal to angle P, we assume like this, and AB by PQ is equal to AC by PR. Then we want to prove that these two triangles are similar. To prove similar, we want to prove some of the criteria. So first one or second one. Here we prove the first one. So we want to show that the angles are equal. Okay. So in the beginning, we wrote here triangle ABC and PMN. The PMN we constructed like this: PM is equal to AB and PN is equal to AC. Then triangle ABC and triangle PMN will be congruent by a side congruency criterion. Okay, and now we consider this given ratio AB by PQ is equal to AC by PR, and we substitute AB and AC by this PM and PN. We will get this one: PM by MQ is equal to PN by NR. Here we can apply the reverse theorem of basic proportionality. We will get MN parallel to QR. Since MN parallel to QR, these angles will be equal: angle Q and angle M. They are corresponding angles, and these two angles are also equal. Okay, so that shows that the angles of triangle PMN and triangle PQR are equal. And this idea, connect to this idea also, that is triangle ABC and triangle PMN are congruent. Congruent means their angles are also equal. Okay, so that shows that the triangle ABC and the triangle PQR have equal angles, same angles. And hence, by the AAA criterion, we can say these two triangles are similar. That's a proof. I hope it is clear. How we can name this criterion with some letters?
SAS Criterion.
Yes, side, angle, and side. One angle and two sides including that angle. So SAS similarity criterion. Okay, in the previous one, I name it this theorem. How we can name the second criterion if three sides are in the same ratio? SSS criterion, side. Here you want to be careful. SSS doesn't mean sides are equal. Sides are in the same ratio only. Okay, and the first one, how we can name the first criterion? AA or AAA. Angle. Okay, three angles equal, or we can simply say AA, because if two angles are equal, then the third angle must be equal. Therefore, it is enough. AA similarity criterion. Okay.